All right, so I am recording both of these reviews, all right, in case you weren't here yesterday or you fall asleep. Heaven forbid you fall asleep in my class. I couldn't imagine, but yeah. All right, I think we finished up with 8 yesterday, right? The perpendicular, parallel, neither. Yeah. All right, so number 9 on the quiz or test, not quiz, but test. All right, I give you 2 points, and I ask you to find the equation of a line through these 2 points. So let me just write down some points, 3, 4, and let's say 0, -3. All right, so again, here's the question. I'm not going to write it down. You can write it down. It says, write the equation of a line that passes through these 2 points. When I say write the equation of a line, I want it specifically in slope-intercept form. That's the one we've been talking about. So what is slope-intercept form, by the way? Do you remember? Yeah, y equals mx plus b. So what I want to do is I want to take these 2 points, because 2 points make a line, correct? If I put a point here, connect them, I get a straight line. I want to find what the equation of that line is. Write the equation of a line. Okay, so the question is, write the equation of a line that goes through these 2 points. And I want it in slope-intercept form. I don't say in the problem, put it in slope-intercept form, but I'm telling you right now, okay, I want it in slope-intercept form. I mean, it's the one that's most common to you anyway, so almost anybody that knows how to do a line probably would put it in that form anyway. So what are the 2 things we need to find with these 2 points? We need to find the what? What is the m? That's the slope. So we got to find the slope between those 2 points, and then we have to find the what? The y-intercept. Okay? So the first thing we're going to do is find the slope. All right, so we take these 2. We should know how to find the slope. Yeah, because I asked you previous on this test to find the slope between 2 points, so you should be able to do that with this. So let's find the slope. So it's the change in y over the change in x. We subtract the y's from each other, so it's 4 minus -3. Make sure you include that negative. Don't just put 4 minus 3. If it's a negative, all right? These could be different numbers on the test, but it'll be basically the same thing. So we subtract the y's from each other, put it on top, subtract the x's from each other, and put it on the bottom, and that gives us 3 minus 0. 4 minus -3 is 7. 3 minus 0 is 3. That's the slope. Is that what I asked for, though? Is that the complete answer? No, I asked for the equation of a line. Let's write it down. I said I wasn't going to, but equation of a line. So that's what we're trying to do, find the equation of a line. Well, we got basically half of what we need to find. We have the slope, all right? Now all I got to do is find the y-intercept. So how do I do that? Well, look at my equation. It's got a y and it's got an x, correct? What does this point have? Right, y and an x, or an x and a y, correct? What does this point have? An x and a y. Now, the cool thing about this, we've talked about this before, the cool thing about this, I can use either one of these points. I could use either one of this. I could use either this x and y, this x and y, or I could use this x and y. It does not matter which point you pick, all right? One person can do 3, 4. One person can use 0, -3. Both of you will end up with the same exact answer. All right, that's what's kind of interesting about this. Which one would you rather use, 3, 4 or 0, -3? 3, 4, let's use 3, 4. And again, it doesn't matter. If you want to use 0, -3, go ahead and do it now. Let's see if we get the same answer, okay? So when I say use it, what are we going to use it for or with? This right here. Well, I'm going to find the plus b, right? So I know the slope. I just found it. It's 7/3. I know an x and I know a y. Okay, I'm going to use the 3 for the x and I'm going to use the 4 for the y. All right, so let's put that stuff in there. So 4 equals 7/3 times x, which is what? 3 plus b. I don't know the b. That's what I'm trying to find. All right, I know the slope. I'm trying to find the b, the y-intercept. Now this works out pretty nice, actually, because look what happens here when I multiply these together. What's really nice about this that happens? Somebody tell me. If I multiply these 2 fractions together. Yeah, because what happens to the 3's? They cancel each other out. Okay, that's the nice thing that happens. Everybody see that? So it makes it so it's not complicated. I don't have to add fractions or anything like that. Get Jay. Get him. Can't have those on. All right. So let's do that. Let's cancel that and that. So let's write it kind of nice. One more step and we're basically done. We got to put it all together, but as far as our math is concerned, one more step. I want to get b by itself, so yeah, I subtract 7 from both sides, so b equals what? -3. Now we got to put it all together to write the equation of a line. We need to make it look like y equals mx plus b. So now I'm just going to put y equals m, found that earlier, 7/3, then the x, then the b. What's the b? -3. That right there is the equation of a line that goes through those 2 points. Yeah. But you get the same exact equation, right? Did you try 0, -3? Did you get the same exact equation? Yep. Everybody hear that? So Alex put in 0, -3 in for x and y right here, and it still comes out to the same exact y-intercept. Yep. Okay, everybody good? That's number 9. So you'll see one very similar to that on the test. The numbers might be different, but it'll come out like an equation of a line. All right. Number 10. Let's see. Okay, this time they ask you to write the equation of a line again. All right, so again, our answer is going to look like y equals something x plus something or minus something. All right. So, but this time they give you a slope. This one's actually easier. This one, to tell you the truth, this is easier than number 9. Probably should have switched the order, but that's okay. They give you a slope, and they give you a point that the line goes through. All right? So they give me a point, so my line goes through -2, -5, and it tells me what the slope of that line is. Right? What I need to do is find the equation of that line. All right? Again, this is easier. Well, I would say this is easier than the last one because they give you the slope. On the other one, you had to find the slope. All right? And this one, they only give you 1 point, so that's the only point that we can choose. I don't have a choice like I did on number 9. All right? So I'm trying to write y equals mx plus b. And I already know one thing. They already give me half of this. What do they give me? Yeah, they do, but the slope, right? They give me straight up the slope, okay? And I got to find the b, the y-intercept. So now let's plug everything in. I know -2 is x. I know -5 is y, so let's put them in. So -5 equals m, which they tell us already. On the other problem, we had to figure it out, but now we know. Times x, which is what? -2 plus b. And now all I got to do is just solve for b, put them all together to get the equation of a line. So let's do this super quick. That's what? -6. Add a 6. So b is what? 1. Our answer, we don't just write b equals 1 and that's my answer. We need to write it as an equation of a line. So let's put it all together. Y equals, right, 3, then the x, and then what we just found, which is the y-intercept. Yeah, it's a positive 1, so we put +1. Yes, ma'am? You don't have to. You can, it would be fine, but you don't have to put over 1, okay? That was pretty simple, wasn't it? Like I said, for the 3rd or 4th time, it was easier than number 9. Usually they get harder, doesn't it seem like math tests? Usually starts off easy, then gets harder and harder. That's not always the case, though, on this one anyway. All right, so we're officially halfway done, so let's try to get done the rest of the test. Quarter of, half an hour. I got 28 minutes. All right, we should have enough time. Oh, we're doing a graph. We are graphing something. So we're graphing this. The graphing part should be the easy part of this. The hard part, or the part that takes a little bit of work, is putting it into the equation of a line. Okay, this is like the 3rd problem now. We've talked about equation of a line. So what I want to do, I want to take this thing right here, this little equation that they give us, and I want to make it look like this. Okay? So basically, I just want to solve for y here. Everybody see that? All right, so I just want to get y by itself. So what do I do with that 3? Give me one good math word. Distribute. So it's 3y minus 6. We distribute again right here. That's -2x plus 6. Why is it plus 6? Negative times a negative. Good. Don't forget that. It's an easy place to make a mistake. All right, well, let's get y by itself. So I'm going to add a 6 to both sides to get rid of that. That cancels. So I've got 3y equals, what do we get? Negative 2x plus 12. Everybody good so far? And remember, the whole thing is to graph it, but it's a lot easier to graph if I put it y equals mx plus b. All right, that's what I'm doing first. That's the first part of doing this problem. It's putting it into the equation of a line. Then after that, I should just be able to look at it, put a couple points, boom, got my straight line. All right. One more step though. Divide by 3, divide by 3, divide by 3. So what do we get? Y equals negative over negative. It's positive 2/3 x plus, Sam, put your phone away, 12 over 3, which is 4. It's negative over negative, isn't it? Yeah, why did I put a negative there? Thank you for that. Yeah, why did I put negative? I don't know. Yeah, it's negative, so it's negative 2 over 3x. Sorry about that. Thanks for catching it. Is that my answer? No, because they asked me to do what? Graph. All right, I got a graph up here, so let's grab that thing. I'll put a graph on the answer sheet for you so you don't have to draw the lines. You're welcome. Let me just stretch this thing out a little bit. There we go. All right, let's change colors. All right, now once you get to this, it should be, hopefully, all right, it should be very easy at this point. So what do we look for first when we graph a line? Yeah, there's the origin, but the y-intercept, okay? The y-intercept, that's what we need first, okay? So it's where it crosses the y-axis. This is the y-axis. It crosses at positive 4, so we count up 1, 2, 3, 4. Put a point right there. So that's halfway done. All we need is one more point. We connect the 2 points and we're finished. So what do we look for now? This. What is that? That's the slope, correct? So you could write it negative 2 over positive 3, or you could look at it as what? 2 over negative 3. Either way you do it, you still get the same. We'll do them both just to show you. All right, let's do the first one. Don't start at the origin. Start at the y-intercept. All right, and I'm going to rise negative 2 right here. I'm going to run 3. So I go down 2, 1, 2, to the right 3, 1, 2, 3. Put a point. What if you did it the other way? What if you did 2 over negative 3? Watch, you're going to get the same exact line. So this one I would rise 2 and run to the left 3, 1, 2, 3. Check it out. Everything lies on the same line, doesn't it? All right, so do this, do this. Stretch it out beyond the graph. Don't just connect the 2 points. Okay, make it look like that. Put the arrows on the end because it is a line. All right, and there you go. That's the answer to that particular problem. Again, I might give you a different slope, or I'm sorry, I might give you a little different equation here, but it'll be pretty similar. Pretty similar. Just the numbers might be slightly different, that's all. Okay? They could be the exact same numbers, all right? On some of these, I might put them exactly the way we go over it. On some of them, I may switch the numbers around a little bit, all right? So just be aware of that. Yes. All right. What do we know about two lines that are parallel to each other? What's true about the lines? What are they? The same slope. They have the same exact slope. Exactly right. So with that in mind, number 12. It says, write the equation of a line. Does that sound familiar? Yeah, it's like the fourth time we've done equation of a line now. Almost. Fourth time. So it says, write the equation of a line that passes through negative 6, 3 and is parallel. I'll just put parallel to this. Y plus 3x equals negative 12. Okay. We want to write the equation of a line. So again, third or fourth time today, what's our answer going to look like? Y equals mx plus b. Very good. You guys are catching on. At least one person is. All right. So that's what we're trying to do. Now, here's the key. The line that we want to write is not going to be this line. It's going to be a different line, but it's going to be parallel to this line right here. So what do they have in common? We just said it a few seconds ago. They have the same slope. So what do you think you want to do with this line right here? Find its slope. That's right. So let's do that. Let's find the slope. So what I would do is subtract a 3x from both sides. Okay. Now, what's the slope of the line that they gave us? It's -3. So what's the slope of the line that I'm trying to figure out? It's -3. Okay, it's -3 because it's the same slope. They have the same slope. They're parallel to each other. What if I use the word perpendicular instead of parallel, which could very well happen? They would be negative inverses or negative reciprocals of each other. Okay? Everybody see that? If I had that same exact problem, but instead of parallel, I said perpendicular, what would the slope of my line be if I said perpendicular? Very good. It's +1/3. Okay? So I could go either way. I could give you parallel. I could give you perpendicular. I'm not going to give you both. Just give you one of them. Everybody understand that? So if I said perpendicular, you still find the slope of the line that they gave us, and then just take the negative reciprocal. All right? Change the sign, flip the number. But in this case, it does say parallel, doesn't it? So what's the slope of my line? It's -3. Now, we're at a spot where we've done this already. What number was that? Number 10. Okay, number 10, we did a problem with the same information. A point, a slope, write the equation of a line. We've done that a couple times today. All right, so that's an x and a y. So again, what am I going to do? Put y equals mx plus b. So what's the y? 3 equals m, which is -3, times x, which is this number right here, -6, and then plus b. And now we just solve for b. That would be what? +18. And then subtract an 18 from both sides, and that gives me what? -15. It's not my answer. My answer is the equation of a line. So I got to put it all together. Y equals m, which is -3, x, and then my y-intercept, which is -15. All right? So that is the equation of a line that goes through this point and is parallel to this line right here. If I was to graph both of those lines, you would see that they would be parallel to each other. Okay? This one would go through -12 on the y-axis. This one would go through -15 on the y-axis. Hopefully you're not just memorizing the steps to do these. Hopefully you're seeing the big picture and you're looking at, okay, I'm trying to make another line that's parallel to this one. All right, so they must have the same slope. This has a different y-intercept than this does. So hopefully you can visualize what's actually going on here instead of just memorizing step by step how to do these. All right, enough of that kind of stuff. Now we completely change gears. We had a quiz. The last quiz we took was this stuff. All right, so let's do this. So it says find f of 4. Remember this stuff? Find f of 4 when f of x is equal to 3x minus 2. All right, pretty simple. Almost everybody got these right when you took the quiz. So it's just substitution. Okay, it's f of x, so we're substituting x. We're substituting 4 in for the x. But we don't have to write f of 4 here. All we have to do is just put 3 times what? 4 minus 2. That's 12 minus 2 is 10. Boom, that's it. I think that might be the same problem that was on the quiz, isn't it? Seems familiar. All right, let's do another one. A lot of people messed this one up. I thought this was just as easy as this one. So let's do it together then. It says find the value. I'll just put find. Is that right? Find the value of f of 2 plus f of -4. And then it says when f of x is equal to 5x minus 3. what you're basically doing is you're doing two of these problems right here and then just adding up the answers. Okay? It's kind of like you're taking number 13, you're doing two of those, right? Two different problems, and then you just add them together. So look, we just put f of 2 in for this. I don't know what some of you guys were doing. I didn't really take the time to look, but I just saw that you got a right answer, wrong answer, but I'm not sure what you were doing with this, but let me show you what you're supposed to do. All right, so what we're going to do first is do f of 2. So pretend this problem just said find f of 2, and that's it. All right, so what would you do with that? You would go 5 times what? 2 minus 3. Let's figure out what that is right now. That's 10 minus 3, which is 7. It's not my answer, though, is it? Because what's it asking me to do? It's asking me to add this one to it. So now I take that same equation. This time, instead of putting a 2 in for x, what am I putting in for it? A negative 4. So now I go 5 times negative 4 minus 3. So that's negative 20 minus 3, which is what? Negative 23. Which one's my answer? 7 or negative 23? Got to add them together. That's right. Okay, see that thing right there? It just says add those two functions together. So I just go 7 plus negative 23. What's that? Negative 16? Is that? Yeah. That's how you do it. We good? Are these the same ones that were on the quiz? Seems like they were. But again, when I make up the test, I'll have, some of them might be the same numbers exactly, and some of them I might switch up the numbers a little bit. All right? So, 15. We're on a roll. You need that? Like that? All right, 15, domain range. I don't even have to do that, do I? Number 15 on the test. Domain and range when they give you ordered pairs, right? Like on that quiz, if you get the quiz out, that first order, I think almost everybody, I think one person might have missed that problem on the quiz. So the domain are all the x's, correct? Yes. All right, and the range are all the y's. So I give you 3 ordered pairs. Let me just do it since we got time, I think. We've got this, that's a 1, and we've got this. All right, and I asked you to find the domain and the range. This is the easiest problem on the whole entire test. It should be. All right, so what is the domain? It's just all the x's. Which ones are the x's? Negative 7, 2, and 11. All right? So that's all you got to do. Okay, I don't care if you put a brace around it or anything. Just put D equals. Put commas in between, though, to separate them. Now the range is just as easy. It's just the y's. So what is it? It's negative 5, 1, and 8. Now, right now, I put the x's like they all happen to come out in numerical order, right? I don't know how picky teachers would be on this, but some teachers would like it in order. Okay, so if it's not in order, you can put it in order. If you just don't put it in order, put the 11 first, I'm fine. I'm not going to mark that wrong. Some teachers might, though. All right, let's do another domain one. This is the one that caused people some problems. Even though I think when I reviewed for that quiz, I think I did this problem twice, okay? And I still got people messing it up. So find the domain and range of this. At the very least, now I don't suggest that you do this, but at the very least, you could basically memorize what this answer is supposed to look like, all right? Hopefully you know why we're doing what we're doing. But, look, reality is, let's get the problem right on the quiz or on the test. This is number 16 on the test. This is number 16. Okay? All right, domain and range. So first of all, let's do the domain. That's the x. What can my x's be? Or what can they not be is the easiest way to look at it. What can x not be? It can't be negative 2. Because why? Negative 2 plus 2 is 0. And can you have a 0 in the denominator? No. All right, that means there is no possible answer for y equals, or f of x equals. So how do I write this, though? What's the fancy way that we write x can't be negative 2? So I'm going to write domain equals, and then put a parentheses, right. So I'm going everything up to negative 2. That goes from negative infinity all the way up to 2, but I don't include 2. Or I'm sorry, negative 2. I don't include negative 2. So how do I show that? A parentheses, okay? That parentheses means it does not include it, okay? Is that everything that can be x? No. I can also have everything bigger than negative 2, correct? So that means I can start at negative 2 and go where? All the way to positive infinity. That's the way that you should write the domain. It goes from negative infinity to negative 2, and then from negative 2 to infinity. Remember, there's a big hole at negative 2. So basically, if you were to graph this, you don't have to. I'm not making you graph it. I'm just trying to get you to understand this a little bit. So if negative 2 is right there, there'd be a big hole right there. Not a big hole, okay? Just one that's at negative 2. So if I was to graph it, it would be everything all the way as close as you possibly can get to negative 2, and then just beyond negative 2, as close as you could possibly get to negative 2, and it's everything like that. That would be the graph of it. Everybody see that? So x could be any single number in the whole universe except for negative 2. All right, what about the range? Well, here's what we do. Instead of f of x, let's write it y equals. So what I'm going to do is I'm going to solve for x this time. This was y equals. I'm going to solve for x. Everybody understand f of x and y kind of means the same thing. All right, so let's do that. Well, I've done this 2 or 3 times at least. All right, so I multiply both sides by x plus 2. So that cancels. Again, what am I trying to do? I'm trying to get x by itself. I want to get rid of that y. So what do I do to get rid of that y? It's being multiplied, so I divide. So the y goes on the bottom. X plus 2 equals this. Subtract a 2. So that's basically what x is equal to. Now, we have to look at it. And again, look at the denominator. The denominator is the key here. What can the denominator not be in this situation? 0. That's right. Okay? That right there cannot be 0. So y cannot be 0. So what we're going to do is we're basically going to write it the same exact way, but instead of putting in a negative 2, what do we put in? A 0. So it goes from negative infinity to 0, and then union with 0 to infinity. That is what I'm looking for right there. You don't need the graph. I just did that just to get you to understand it a little bit better. We good? All right, let's do some graphing. Let's grab this graph that I did up here. Copy that, and then let's scooch down. We'll do all these on just the one graph, and then I'll just erase it when I'm done with it. Okay, so I want to graph. These are all graphing, and it's the first one is y equals x squared plus 1. Now, there's no calculator is going to be allowed on this. Everybody understand me? All right. So you got to know how to add and subtract negative numbers, know how to multiply, all that kind of stuff. So I am not allowing you to use a calculator on this test. You don't need it, really, on any of them. But what does this look like? What is the shape of this particular graph? It's a parabola. So it's going to look like that. Okay? It's going to be kind of like a U-looking thing. All right? This is a parabola. What is the 1, the plus 1 do to my graph? Okay, and where do I start? On the y-axis at what number? At 1, exactly right. So I start right here. Oops, let me make it look like a dot. Okay, that's where I start. Now, what's the shape? Now look, I'm very, very lenient on how well you draw your graph, okay? But you should be fairly accurate. So I go over 1 and what? Up 1. And if I go over 2, remember I'm squaring. If I go over 2, I go up what? 4. 1, 2, 3, 4. Yeah? Who is it? Okay. All right, so I've got one here, and I've got one here. And then I just try my best to graph it. There we go. That looks actually half decent. And that's what it would look like, okay? Again, I'm not being super picky. Now, if you do this, watch this. If you do this, I will not give you that. That's not close, all right? At least go over 1, up 1, all right, to get the width correct. Okay, don't be all crazy looking like this, okay? But if you're relatively in ballpark, I'm going to give it to you. I'm not going to be super, super picky on it. Everybody good with that? Okay, that was easy. The next one is a cubed. So it's y equals x cubed. Let's see, what did I put? Minus 3. I think this was all from the quiz, right? Exactly from the quiz. But I'm going to change it up because I'm going to make it up tonight. I'll change it up a little bit. So a lot of, actually, no, I think people are pretty good with this. So again, this minus 3 is at the end of it. It's not inside of the x, is it? Or it's not inside of the squared. This is completely outside of that x squared. This minus 3 is completely outside of that x cubed. So that means when it's like that, that means it either goes up or down, or it starts up and down, all right, instead of at the origin. So what do you think this means? If plus 1 means it starts up 1 on the y-axis, what do you think the minus 3 means? We go what? Down on the y-axis. So 1, 2, 3. Actually, I think this is a little different from the quiz, isn't it? I don't think we went down like this. So how do I write an x cubed? What's an x cubed look like? Well, it starts like this, and then it goes down like that. Yeah, it's kind of like half a parabola, but you take the other side and you flip it, right? That's basically what it is, all right? So again, what do? I'm going to go over 1, up 1. Then I'm going to go over 1 to the left and down 1. Again, at this point, I don't care that you go over. If I go over 2, technically, if I want to be really careful about this, I go over 2 and up how many? 8. I'd go 8 because 2 cubed is 8. You got to start from here. So it would go like this, and it would go like this. All right, and again, I'm giving you some flexibility on how well you draw these. Some of you guys are doing this. You're going like way out here like this, and you're going like way out here like that. All right. Remember, you only go over 1, up 1. It's fairly steep, and you go up 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8, right there. See, it's a relatively steep graph. But again, I give you some leeway on it. But it's got to start. The one thing I will not give you any leeway on, it's got to start right there at that -3 in this situation. All right, we're almost done. And time is almost run out. Okay. All right, what's the next one? The absolute value one, right? All right, and so this is one where a lot of people mess this up. What do you think you did wrong? Let me say that. What do you think you did wrong on this one? Okay, some people moved it to the left, that's true. Or some people moved it down 3, okay? But remember, this is not outside of our function. This is inside the function this time. This is inside our absolute value function, okay? So when the minus and the plus is inside the absolute value, that means we move it left and right. Now, the weird thing about this is it looks like you might move it to the left, doesn't it? But when it's inside the function, we move it in the opposite direction. So this actually starts where? To the right. How many places? 3 places. Okay? So it starts right there. Now it's absolute value. I think most people understood what the absolute value is supposed to look like. It's right, it's a V, and it just, look, if I go over 1, up 1, do you see this? Just to kind of get us going. Then right here, right there. And then I just connect straight line here, straight line there, and that's what it should look like. All right? You can be really accurate on that. That's really easy to be accurate on. All right, one more, and then we'll be done. It's kind of like a combo, isn't it? Go ahead. This one? Yeah. No, this one, remember, it's not inside of the squared. Okay? It's outside. See how you have the x squared here and the plus 1 there? Now watch this though. It's a good question. Watch. I don't know if I will or not, but I could do this. Say x plus 1. What would that look like? Because we're actually going to do that in the next problem, to tell you the truth. This would go to the left, but it'd still be a parabola, right? Still go up, but it would move to the left one place. Okay? You see the difference between this and this? Okay. So the one that we're doing right now absolutely has what we're talking about right now. It's kind of a combination. So this is, yes. You can just grab it. You don't have to ask. All right. So now, what does that -4 do to my shape, to my parabola? It moves it up and down because it's outside of the function, correct? It's outside of the function. So this moves it down 4 places. What does this -1 inside of the square do? Very good. You move it right. So this goes right 1 place, and it goes what? Down 4 places. So where does it start? It starts at what? 1, -4. You see what I just did right there? I just put my starting point. All right? This right there means it moves to the right 1 place. This right here means it moves down 4 places. So if I start at the origin, going to the right is 1, going down is -4. So I go 1, -4. 1, 2, 3, 4. That's my starting point right there. What's my shape look like? What kind of shape is it? How do you know it's a parabola? Because it's squared. Not x2, it's x squared. All right. Now, again, you want to be relatively accurate on this. Go over 1, up 1. Go over 2, up what? 1, 2, 3, 4. All right. Do this. Do this. Did I go over? I went over too far. Forget that. There we go. Then up to, there we go. That's better. Everybody see that? And that's the parabola right there. And again, if you miss it by a little bit, I'm flexible with these as long as you start at the right point and the shape looks relatively like it's supposed to look. All right, then you're good to go. Check that out. We did 20 problems right at the end of class. Well, we didn't do 20 today. What did we do today? Like 12 of them? Okay. All right, test tomorrow. Be ready for it.